Yes, welcome to this teaching today about algebraic structure. Okay, an algebraic structure is nothing but a set with one or more binary operation is called an algebraic structure. A set with some one or more than one binary operation is called an algebraic structure. Algebraic structure means nothing but a set with one or more binary operations. I can give an so definition goes like this. Okay, so let X be any set. X be any set. Any set. Okay, right. And 2, I am taking 2 here, 2 binary operation, and star and round plus, star and round plus, or binary operations, are 2 binary operations, 2 binary operations, binary operation, okay, binary operations. Okay, binary operation. Now I am giving a mathematical structure like this. X, the set I am taking into account, and the 2 operations, one is star plus and another one is round plus, star and round plus. Now this structure, I call it is an algebraic structure. Okay. Now the bracket x comma star and round plus, where x is a set and these 2 are binary operation, is called algebraic structure. Is called algebraic structure, I say. Okay, algebraic structure. S-T-R-U-C-2-R-U structure. I can give a lot of example for this. Okay, take for example, I can give a lot of example for this. Say, take for example, the first example I am taking here is set of real numbers, and then multiplication and plus. You remember that multiplication and addition are 2 binary operations. We already know that. This is one binary operation, this is another binary operation, this is set of real numbers. So definitely this structure, mathematical structure, I call it as algebraic structure. So this is a good example for algebraic structure, where R is a set of real number, this is multiplication, this is addition as we define in the number theory. Another example I can give is I can say that universal set. Okay, the universal set union and intersection. So this universal set, of course, is confusing with this particular operation. Therefore, why can't I replace by any other operation? Okay, any other notations I can use there, so that you can understand that very clearly. I am taking this as I can take this as a set, the universal set, I can say. Okay, I can say this is a universal set I am talking about. This is a union operation, this is an intersection operation. In that particular case, this is an algebraic structure. This is what we call it as algebraic structure, because that satisfies some conditions that we will see later. But this structure is a good example for algebraic structure. Okay. Similarly, in the discrete mathematics also, we can take set of logical sentence. We can take what we call the true or false. Am I correct? True or false. In that we apply so many rules there, or and. There is also a good example for the algebraic structure. Okay, so third one I can take is a logical theory, discrete mathematics. The discrete mathematics, suppose L is a logical set of logical sentence, then N and R are good example for algebraic structure, where L is a set of logical sentence, and this is AND operation and this is OR operation as we defined the discrete mathematics. So it's a good example for algebraic structure. Okay. Now this algebraic structure have some important properties. Okay, some important properties. This algebraic structure, this or this or this, generally this has some properties like this. The first property is commutative property, second one is associative property, and third one is distributive property. Commutative property, associative property, and last one is called distributive property. Okay. Yes, definitely. So I take a general case. In the general case, we will discuss about these three properties of the algebraic structure. First one is commutative. Okay. Now let me take another ink so that it will be very easy for you to differentiate the properties and other things. Okay, so I will take a red color now, so definitely it will be very understandable for you. What's commutative property says? Okay, for all x, y two elements belongs to the algebraic structure or belongs to this particular x. The algebraic structure, x is a set, implies x binary operation y equals y binary operation acted upon x. So this is true. For all x, y belongs to x, if this star is a binary operation acting on the set of elements of x, then this is always true. This is always true. And in this particular case, if you take this particular example, I can take this also. Round plus also is true. Round plus also true. Okay, this also round plus always true. Very interesting, is that not? This property we call it as commutative property. I mean, we can commute x and y anyway. First x, then y, or first y, then x. Okay, this property we call it as commutative property. Next one is called an associative property. Okay, so what the associative property says, for all three elements I'm taking there, x, y, z, belongs to the particular set in the algebraic structure, implies we can associate in any way. First I am associating x and y. I am associating x and y. Then I am associating z. Okay, see the way I am associating. First I am associating x and y. Then afterwards I am associating z. Now unlike this, I am associating differently. How? I am associating last two elements out of these three elements. Okay, last two elements I am associating. Then afterwards I am associating by this binary operation the last element x. Okay, so what's the meaning here? If you take any three elements, we can associate anyway. First, second, then third, or second, third, then first. Still, the meaning is equal. The meaning is equal. Either side, both are equal. Left hand side equals right hand side. And this property we call it as associative, meaning we can associate in any way as we like. As I already told you that if this is another operation, we can do like this, round plus. Here also round plus, because round plus is a binary operation. That is true for this binary operation also. Right. What about the distributive property? Okay. Distributive property means what? Now I'll take the three elements again for all x, y, z. Okay, belongs to the set X as we define the algebraic structure. Implies, okay, implies. What it implies? Look at this very seriously. X star, x star, y plus z, or round plus empty here, round plus z would be equal to x star y, then round plus x star z. Now what we do here, the two operations must be needed here for distributive properties. Okay, first one is x, or we can say that this binary operation over this binary operation is distributive. I mean x star y round plus z is equal to x star y round plus x star z. Okay. Now look at this distribution. X is distributed over y with respect to star. That is the meaning here. Distributed. X is distributed y, then x is distributed to z. Okay. So this particular property we call it as a distributive property. Okay. So I can take a lot of examples, but because of the time constraints, I have to see there is some important ideas here. Now I'm taking this. Now let me take another ink so that you can understand very easily. Now this is what I am taking now and applying these properties. First property is commutative. Okay, for all x comma y belongs to the set of real number R implies x plus y, the addition of x and y is exactly equal to y plus x in addition. Okay, 5 plus 2 equals 2 plus 5. Okay, therefore commutative properties satisfied. You take any two elements in the set of real numbers, this is satisfied. So this particular algebraic structure satisfies commutative property, right? Now next I am talking about the associative property. Associative property for all x y z definitely belongs to R implies the associative property says that x plus y plus z equals I am associating last two elements, x plus y plus z. True. So associative property satisfied. Am I correct? Similarly, the distributive property also satisfies. So with that, I come to the end of this class. Next class, we'll see another topic. Thank you, my friends.